name is Clayton Upcraft, and I will be going over the design of the combined loading machine. On my design team was John Rutkowski, myself, and Cayla Meyer, and Dr. Ragai was our advisor. I'm going to start today's presentation by going over quickly the need and problem statement. So this originally was an MK Morris project, and it was our intended customer. It currently is an internally sponsored project. So originally, MK Morris, they are a producer of saw blades, and they were looking for a machine that could test the bandsaw blades by applying a repeated combined load. So that's a torsion load and an axial load simultaneously. So working with our sponsor, we established some constraints. It must be powered by a 240 volt or 120 volt standard voltages here in the United States. It has to apply a 5,000 pound axial load and a 120 pound-foot torque at a minimum. We wanted at least 90 degrees of torsional rotational travel, able to perform a fatigue testing with frequencies greater than 25 hertz. And then onto the controls, we wanted load profiles, data logging features, and at the end of the day, this machine must fit on a workbench. So we're going to establish a size of 6 foot by 3 foot. Taking that criteria, those constraints, the team went off, we made some concepts, and this was the final design that we reached. So I'm just going to take a minute here and go over how this machine actually works. So to apply the axial load, there's a hydraulic cylinder here. This hydraulic cylinder will apply a force on the back of a moving plate here. This moving plate rides on these 3 column members, if you can visualize that. The reason this is we needed somehow to get the torsional load off of the hydraulic cylinder, as these are not intended for that. That's a function of the moving plate, is to take the torsional load from the fixture and apply it to these columns. On the other side here, to our right, we have the hydraulic motor. The hydraulic motor is what produces the torsional force and applies it to the back of the moving side of the fixture on our right side here. And then the test specimen is going to see this axial and torsional force that is controlled by the hydraulics. The plates are responsible for keeping everything in place. We have 3 plates here. We have our top plate, which mounts the cylinder. We have our moving plate, which mounts the fixture and takes that torsional load and applies it back to the frame. And then we have our base plate here that mounts the motor, as well as takes the axial load and distributes it to these 3 columns. These 3 column members are integral to the frame function, and they see the compression reaction load from the tension testing. And with that, we will conclude today's video. Thank you guys for watching.